The World Health Organization has found that over 1 million people will die every year attributable just to lead poisoning. My main focus is looking at how we detect heavy metals exposures. We can have a slight increase in the lead levels in children, and you can relate that back to 10-point decrease in IQ. Well, the background lead exposure in India is almost 6 times higher than that in the US. So if you want to make a drastic impact on the world, if you were able to do these lead measures in a place where you have 6 times more exposure, it would be drastically more impactful. The current study we are doing to look at some of these heavy metals and relate them back to health is we have a cohort called the Health and Retirement Study. And this is a nationwide cohort where we have samples that we've collected from everyone across the US. And using those blood spots, we're hoping that we can look at these heavy metal toxicants, lead, mercury, cadmium, and arsenic. No one has ever been able to do blood spot measurements for heavy metals previously. So this is a very unique opportunity for us to tap into blood spots that have been collected nationwide. The unique thing about X-ray fluorescence is that it's non-destructive and we can sample across a wider area of the blood spot. Most other methods for doing any of these analytical techniques related to heavy metals would be destructive for the sample itself. So the cohort I'm working with now, they previously collected these blood spots in order to do some DNA tests on them. And now they have these blood spots and they're willing to give them to us, partially because we can do this analysis non-destructively and give the blood spots back to them after we're finished.
We worked with Aaron to develop a method that works for his materials, that measures the elements that he wants to measure, the lead and the arsenic, and to set it up in the software, in the system. And then now that he's got that operational, and initially he did it on one unit, then he was just able to copy that to other units. And in the future, perhaps if more people adapt this technology, then it's very easy to transfer the methods onto other instruments.
The instrumentation we use for this particular method is a benchtop X-ray fluorescence unit. Because of the form factor of these benchtop XRFs, it really opens up the idea that we could deploy these in many different areas around the world. In addition, the factor that we can train people in an afternoon on how to operate these systems makes it incredibly easy to do. A lot of the work I'm doing and the research I'm involved in environmental health is trying to make the world a healthier place to live in. And it's also trying to help clean up the mess that we made in the world and make it a more clean environment.